Time for horizontal and oblique asymptotes. I may have to backtrack and look at the vertical asymptotes again. These are different because horizontal and vertical or oblique and vertical are different. That means you're going to have different tests, and yes, it'll take some practice to keep it straight. So horizontal asymptotes are imaginary horizontal lines, so dashed when drawn. I'm going to keep using green. They're imaginary horizontal lines that the curve must use as an asymptote. That means that your curve gets closer and closer and closer to the asymptote, but it isn't going to touch it out on the edges. However, unlike vertical asymptotes, the curve may cross a horizontal or oblique asymptote somewhere in the general center. So that doesn't mean exactly 0, 0. That usually means within the fives, as in somewhere between +5 and -5 on the y. This is something you may have looked at in grade 11, I'm going to guess, and told that you're not ever allowed to cross any asymptote. That is not actually the case. Horizontal asymptotes may be crossed. It's not a for sure that they will. It's not a for sure that it won't. It depends on the results of your tests and other information. A horizontal asymptote helps to describe the general behavior far off to both sides of the graph, not near the middle. So just as, and I've got it here, just as vertical asymptotes, for example in this picture, were telling you what was happening at the very top and very bottom, so the edges of the graph on the up and down, horizontal and oblique will tell you what's happening near the outside sideways, not near the middle. Oblique asymptotes are an asymptote that you get if you don't have horizontal. So there is a chance that you get a vertical and horizontal. There is a chance that you get a vertical and oblique. You cannot have an oblique asymptote and a horizontal asymptote at exactly the same time. That is because they conflict with each other with their characteristics on how the function looks. So for rational functions, and we're talking about linear oblique asymptotes, so not vertical, not horizontal, slanted in some way, linear oblique asymptotes occur when the degree of the numerator is exactly one more than the degree of the denominator. Every other situation will give you a horizontal asymptote, but if the degree of the numerator is more than the degree of the denominator, then you have oblique. We're going to deal with exactly one more. The equation of the linear asymptote can be found by dividing the numerator by the denominator. And I'm sitting here smiling because this links our first unit with our second unit. You need to be able to do long division or synthetic division, because in order to divide polynomials, a top function by a top function by a bottom function, you need to do long or synthetic division. Again, I promised you in this class that you would only have to learn one or the other, and synthetic division would always work, and that is still the case. Oblique asymptotes in this course are straight lines when you have the degree of the numerator is exactly one more than the degree of the denominator. But it's not always the case. If the difference between the top and the bottom is more than one, then you have another kind of asymptote. Maybe a parabola, maybe a cubic, maybe a quartic. Depends on the degree difference between the top and the bottom. You only look for asymptotes when there are letter fractions. So we've discussed the fact that you no longer, when you have rational functions, you no longer get to look for double roots or points of inflection. Instead, you get to look for asymptotes when they're letter fractions. And you only look for oblique asymptotes when there is no horizontal asymptote, and that happens when the numerator has a higher degree than the denominator. So we're going to look at some questions. This may take a bit, which is why I've separated the two notes, vertical asymptotes and these ones. But next slide, regardless of whether you're looking for horizontal or oblique, the steps are the same, and I will come back to this if necessary. Let the x values approach positive, negative, infinity, so this will be worth 1 mark. Divide, sometimes long divide, as instructed in the question. Your answer will look like y equals a number if there's a horizontal asymptote. Your answer will contain the variable x on the right-hand side. It still has y equals. You'll probably have y equals mx plus b for linear if there is an oblique asymptote. Your tests, and I'll go over this as well with an example, you test very large and positive and negative values. So a 10 and a negative 10 are big enough. And you substitute that into the function minus the horizontal asymptote or the function minus the oblique asymptote. If you end up with a result that's positive, you draw the curve above the asymptote, so you put your little arrow above the asymptote. If the result is negative, you draw the curve or the little arrow below the asymptote. So we're going to go through a question, and I'm going to tell you right now that this question has a horizontal asymptote and no oblique asymptote. So take a sec here, and remember you can pause anywhere along this, and you can contact me and ask me for any clarification, help, whatever the case is. So when you look at this question and you decide, oh, look at that, you have a numerator degree. Let's do this in purple like we did in the first unit. That degree is 1, and that degree is 1. That means you have a horizontal asymptote. Therefore, I'm going to say no oblique asymptote right away. Okay, so I've covered that there is none of these. So now I have to take care of horizontal asymptotes. Now you need this line right here, and that will cover this, and that will get you a mark. Everything you do from this point forward in this section here requires this line. So if you start doing all the rest of the stuff and don't have that line, all the rest of the stuff is kind of mathematically incorrect. So you have to pull off that first line. So you need this to do it. So I am going to use my good old creative pen to give that a happy face. So the next thing you do is you look at the highest degree overall in the question. And the highest degree overall in the question is 1. So you have to take everything in this question, so 3x and x and 2, and you have to divide it by x to the degree of 1. And then you have to clean it up. So this is me dividing. So for instance, 3x divided by x is 3. X divided by x is 1. And 2 divided by x cannot be cleaned up at all. Your y equals is still sitting on the right-hand side. Now, because you have said that x is a very, very large number, either a positive large number or a negative large number, that means this quantity right here, this little fraction that's there bothering you maybe, is actually getting really close to 0. So if I take the calculator and I do 2 divided by 10, that gives me a decimal. Try to remember 0.2. If I take 2 divided by 100, that's even less of a decimal. If I take 2 divided by 1 million, which is still nowhere close to infinity, I get a smaller decimal. So if I keep getting closer and closer to infinity, my decimal keeps getting littler and littler, which means you get to say that that is essentially insignificant or 0. So what happens is that you have this, and I'm showing every step of the process, which is this which ends up giving you a horizontal asymptote of y equals 3. It is illegal, mathematically, to say this. This is not graphable. There is no HA axis. So what you need to do is you need to make sure that you have y equals, which is why it's so important that I keep my y equals down the side. So now I have a horizontal asymptote, and I have a number as a horizontal asymptote as promised here. Your answer will look like y equals a number if there's a horizontal asymptote. So now I can go on and I can perform the tests, and then I'll show you how to graph this or sketch it. So I'm going to pick negative 10 and 10, so I'm going to keep my left on my left and my right on my right. So these are x values. And I'm going to substitute them into the original equation minus 3, because 3 is the equation of the horizontal asymptote in this question. So I'm telling you I'm doing the test. So f at negative 10 minus the horizontal asymptote. That means 3 times negative 10 over negative 10 plus 2 minus the horizontal asymptote. And if you're wondering where this came from, it came from here, the original equation. Now there's no shortcuts here because we have a minus and it's not all multiplying and dividing like it was in vertical. So I have to actually do the math. But just like vertical, all I have to do is figure out whether my result is positive or negative, so I can write above or below. So calculator time. $30 negative divided by 8 negative equals that, and then I'm going to minus the 3, and I get, don't care about that number. What I care about is that I end up with a positive result, which gets me to say above. And then I can restart this whole thing, and I can put in 10. So all I'm doing is looking at this because I can't see that anymore. So it'll be 3 times 10. Can you see I can do math in my head? 3 times 10 over 10 plus 2 minus 3. 30 over 12 minus 3. And do not assume that this is going to alternate. Just like vertical asymptotes, this is complete crapshoot. Although don't be surprised if it does alternate. So there's the result of the fraction. Minus 3 equals, don't care that it's 0.5, I care that it is negative, which means below. So I'm going to take a little break here, and the break is so that I can set up my axes. Okay, axes. Drawn with a ruler, labeled. I need a horizontal asymptote through y equals 3. So here's y equals 3. I can draw an asymptote through there. And just like vertical asymptotes, I need to put a label on that. Notice how my horizontal asymptote is horizontal. Dig out my red pen. So at negative 10 on the x, which is down here, because this is the x negatives, I have to put my little arrow, my curve, above the asymptote. And down here, where it's x equals 10, I have to put my little arrow, my curve, below. Now what will happen is that we will eventually be able to piece together, and this will be tomorrow, we'll be able to piece together other information from vertical asymptotes and x and y intercepts, don't forget those guys, and you'll be able to finish off the picture. But right now, today, I want you to be able to pull that off. So let's look at some other questions. Can you tell which of these questions have oblique asymptotes and which of these questions have horizontal asymptotes? Because I can. And it's not because I'm brilliant, it's because I can pick up the pattern. So this question will have a horizontal asymptote. This question will have an oblique asymptote. Now let's talk about the oblique before this one. I just got a little cocky. So with this question, your top degree is 2, your bottom degree is 1. That is a difference of 1. That makes an oblique asymptote, especially since the top is bigger than the bottom. The top is not bigger than the bottom here. This is 0, this is 2. That automatically makes a horizontal asymptote. This one, 2 on the top, 2 on the bottom. That makes a horizontal asymptote because they are the same. 3 on the top, 1 on the bottom. That makes an oblique asymptote, but it certainly doesn't make a linear oblique asymptote. It makes something else. In fact, because this is 3 and this is 1, the difference between it is 2. So you'd have a parabola asymptote. And we'll have one more question in a few minutes. So let's take a look at some of these questions. I am going to take a little break just to move some out of the way. So as discussed, this has an oblique asymptote, but I am going to go over question C first because it has a horizontal asymptote. And that's a little bit more familiar. So the steps are number 1, you tell me that you're finding the horizontal asymptote as opposed to some other step like x-intercept, y-intercept, vertical asymptote, and you take and you must write this down. Remember, everything else follows from that, so if you don't write this, you don't get one of the marks. Then you can take the original question and divide every single term, so in this case it's 1, 2, 3 terms, divide every single term by the highest power of x. So the highest power of x this time is 2, so I get to put x squared under there, x squared under here, x squared under here, and clean it up. So the top doesn't clean up at all. These two x squareds will cancel and become not 0 but 1. And this final chunk of information, the final term, doesn't change at all. But anytime you get left with an x or higher degree in the denominator after you clean up, because you bothered to say this line right here, these are insignificant and they head to 0. Which means I end up with 0 over 1 minus 0. That's 0 over 1. So I end up with a horizontal asymptote of y equals 0. So, test time, y equals 0, y equals 0, y equals 0, y equals 0. I'm going to put in negative 10, subtract off the horizontal asymptote. So that's 4 times negative 10 in a bracket squared minus 1, subtract 0, which won't make a difference at all. I can tell if you forget something other than 0, but if you forget to do that one step with 0, you get off a little bit free. So that's 4 over 99 minus 0, so that ends up being positive, and positive means above. This time I'm putting in 10 minus the horizontal asymptote, so that's 4 over 10 squared minus 1 minus 0. So that's 4 over 99 again, minus 0 is positive. See, I told you it didn't always alternate. That's also above. So time to draw my picture, my graph, my sketch in this case. Label X and Y. Draw X and Y with a ruler. Draw yourself your asymptote. This asymptote is y equals 0. 0 is here. Just like with vertical, I make it just a little bit off because guess what? We have to label it anyhow. And on the left, which we did first, it was above, so I put my little arrow above. And on the right, it's also above. And there you have it. So let's go and talk about this one. So this one has an oblique asymptote, and because it has an oblique asymptote, or it has an oblique asymptote because the top degree is 2 and the bottom degree is 1, and subtracting those is 1, so you have a linear oblique asymptote. And that means you have to divide. So you don't have to worry about this kind of stuff. Instead, you can divide. Now, let me pause and think about that statement for a second, because if there's a way to take care of this in a different way, I'd like to share it with you. So let me have a think. Well, I'm glad I had a think, because I think I can avoid having you guys, because we're talking about linear, I can avoid having you do long or synthetic division. Now, I will show you everything with this question because it's a video. I have time for this. I have unlimited time. But if we pretend like we don't even know that this has no horizontal asymptote. I mean, you're really supposed to know. We're doing oblique. Your first line should be the same. So let's pretend we're just having a sleepy morning. We're going to take 3x squared, and we're going to take 5x, and we're going to take negative 6, and we're going to take x, and we're going to take 2, and we're going to divide everything by the highest power of x, which in this case is x squared. Then we're going to clean it up. So x squared and x squared cancel each other out. Oh, I lied. This isn't going to work. Sorry, guys. There's no shortcut. There's also no way to avoid this. We're going to have to long or synthetic divide. So I'm going to do long division first and show you what happens. Remember all that descending order stuff and gaps, and there aren't any gaps, and it's already in descending order. If you are a synthetic divider, my lines aren't coming out very straight today. Opposite of the denominator. So x into 3x squared is 3x. Multiply around. Subtract. Gone. Negative 1x subtract 6. That leaves you with negative 1 subtract negative 4 is the remainder. Let's see what happens over here. Negative 2 times 3 is negative 6. Add. Negative 2 times negative 1 is positive 2. Add. Out of numbers, that's your remainder. So I want to tell you what this means. This means that your original equation, which I'm writing down just for kicks, and so I can see it in a minute, And sorry about that blip in the action. I'm obviously doing way too much math this weekend. So that's the original equation. You have now formed a different equation that is the equivalent of this. And it is that this divides in 3x minus 1 times, so that's this and this, with a remainder of negative 4 that sits over your original denominator. So it's almost like this is your improper fraction and this is your mixed fraction. So, time to do our test. Oh, my bad. Oblique asymptote is the y equals 3x minus 1 part of it. So it is the non-fraction, it's the quotient, that's why you pulled off either one of these. So that's your oblique asymptote. The test is going to be the same, but more complicated, meaning that we are going to take large values, positive 10 and negative 10, and we are going to put it into the function minus, in this case, the oblique asymptote. Now that looks a little bit fancier. I'm going to tell you I'm going to do my test and do my negative 10 over here and my positive 10 over here. I can't believe I got so cocky that I thought I could shorten things up, and obviously I couldn't. So I'm going to get over that eventually. Here's me putting negative 10 into the original function. And here's the awful part, and why oblique asymptotes are not your friends. You have to put negative 10 into the equation of the oblique asymptote as well, because unlike horizontal asymptotes, they aren't just numbers, they're actually expressions or equations. So we were here. So I'm going to do some mental math here. You can do it on your calculator if you like. This is 300 minus 50 minus 6 over negative 8 minus negative 30 minus 1 is negative 31. So now it's time for my calculator. Whoa! So 300 minus 50 minus 6 is equal to 244. And 244 needs to be divided by negative 8. And then I have to add, because subtracting a negative is the same thing as adding, 31, and I end up with a positive answer, which means above. Remember that that does not guarantee that we are alternating. So now, 10. Little mental math again. 300 plus 50 minus 6 all over 12 minus 30 minus 1, which is straight up 29. Time to get a little lazy. 350 minus 6 is 344 divided by the 12 is equal to that, and then I minus the 29 and I get a negative number, which means below. All right, time for this graph. Now remember that this is not a graph, it's a sketch. So a lot of time oblique asymptote questions in this course will be find them, do a test, stop, because, I mean, do you remember? Hopefully the answer is yes. Do you remember how to graph this? This is a line, and it's y equals mx plus b. So that means that I have to go to -1 on my my y-axis, and then I have to go up 3 over 1 from there, reasonably to scale, and then I have to draw my asymptote. And in addition to that, I need to label it. Now here's the benefit between doing left on the left and right on the right, or first and second. I know that on the left, which is down this end, I have to put my arrow above the asymptote, so that's like that. And over here on the right, I have to put my arrow below my asymptote, so I end up with that. Okay, so we've got a graph for that one, a graph for that one, a graph for this one. How about this one? Just checking what else we have to do. All right, so as we discussed, this is a horizontal asymptote because this is degree 2 and this is degree 2. If it makes you feel more comfortable, please take x minus 1 squared, write it out twice, and FOIL. And that will give you, maybe for you personally, a preferable version of f at x. And because I recognize that this is a horizontal asymptote because they have an equal degree, I'll need this, and I'll need to return to dividing everything by the highest power of x. In this case, x squared. Now, I do want you to know that if you can convince yourself that you can have minimal steps, feel free to do that. For instance, I can look at this and I can say, well, there's going to be x's on the bottom, that's a 0. There's going to be x's on the bottom, that's a 0. This will have an x on the bottom, so that's a 0. This will have an x on the bottom when we clean it up, so that's a 0. So you end up, because you've said this line, with 2 cancels, plus 0 minus 0, which is 2, over 1 minus 0 plus 0, which is 1. So you end up with a horizontal asymptote of y equals 2. And I've done a little bit less work in this case. Now I get to do my test. Like, that's a good thing. So f at -10, subtract off the horizontal asymptote. So I'm going to take my new version and put -10 in there. And I'm super excited. I like horizontal way better than oblique because I know I don't have any more substituting. I can just subtract off 2. So 200 minus 40 minus 3 over 100 plus 20 plus 1 minus 2. So 200 minus 40 is 160. 160 minus 3 is 157. That's 121 minus 2. And I realize 2 equal signs in one line is not a good thing, but this is just a test. Good form isn't really necessary as long as you're communicating your thoughts. Minus 2 equals a negative value. So below. And then redo the whole thing for 10. So let's see if I can not screw this up. Famous last words. Oh, come on. It's been a while since I've done that. All right. 200 plus 40 minus 3 over 100 minus 20 plus 1 minus 2. So that's 240 minus 3, which is 237. 80 plus 1 is 81 minus 2. 237 divided by 81 equals minus 2 equals a positive number, which is above. All right. Line maker. So y equals 2. Horizontal asymptote is say there with a label. So lines get drawn with rulers and everything gets labeled. So on the left, which I did first, it's below. So I put my tiny little arrow below. And on the right, it's above. So because I have the luxury of doing this, I'll put it above. And that's what I expect you to be able to do with horizontal and oblique asymptotes. Put on those arrows. Now with this particular question, I want to go back and just do a little review of vertical asymptotes. So what I would like is I need my snippy tool. I'm going to do damage. I'm going to go back and look at vertical asymptotes with this. Just as a review, because really it's going to be packed together in the next lesson anyhow. Vertical asymptotes was blue. So you tell me you're doing it. Remember what you're supposed to do. You're supposed to take the denominator. So I'm going back to the original, and I'm making it equal 0. It's the same bracket twice, so I'm only writing down the green once, and we end up with a vertical asymptote, not of 1, but x equals 1. So the reason I picked this is because I knew that there was only a test that is left side, right side for 1. So on the left side, I'm going to use 0.9, and on the right side, I'm going to use 1.1. And I'm going to put that back in the original. So I'm going to use the calculator here to its fullest extent. And I'm putting in 0.9. So 2 times 0.9 squared plus 4 times 0.9. Damn. 2 times 0.9 squared plus 4 times 0.9 minus 3 equals a positive. Now, I'm going to be super smart here. 0.9 in this bracket minus 1 is negative. Negatives being squared are positive. A positive divided by a positive is a positive, so we can say that this is an up arrow. Now I'm going to go through the same process for putting in 0.1. Clear that out. And I'm not needing brackets because my numbers for testing are not negative. So that's positive. Not cooperating at all. Why isn't this cooperating? Come on. (1.1) in here minus 1 is 0.1 squared is still positive regardless of its value. A positive divided by a positive is a positive, which again is up. You thought I messed up. All right, so time to make my vertical asymptote. 1, vertical, labeled x equals 1. In both cases, I am up. So on the left, I put a little arrow up, and on the right, I put a little arrow up. So this is where you have to realize that what is very likely is that you'll join those guys, and what is very likely is you'll join those guys, and we've just crossed over the horizontal asymptote. So that is legal going back to this. So it may cross it. Tomorrow, what happens, sorry, next lesson, what happens is you will be asked to fit everything together, including backtracking, including backtracking all the way to the fact that we have to do x and y intercepts with this. So this will move a little fast and furious. So let's get rid of, what the heck? I'm not doing very well with technology right now. Let me take a break, fix it, and I will come back at you. This is embarrassing. There, fixed it. Next question. We are not finishing entirely. I'm going to cough, but it's seasonal allergies. Excuse me. This one is the one where it is not in this curriculum, and that's why I want to discuss it. This has a degree of 3. Denominator, degree of 1. Subtract means you have 2. That is a non-linear oblique asymptote. In fact, it's a parabola asymptote. So instead of, where did we do it? Instead of having an asymptote that is linear like this and getting close to it from above or below, you're going to have something that looks like a parabola and having some arrows. This is not high school curriculum. But I would feel terrible sending you off to wherever you're going to without having mentioned that this gets, I guess, worse if you want to look at it that way. It gets more complicated as you go on in math. So math doesn't stop, unfortunately, unless you stop taking math. All right, so here's our actual last question. So we're determining the asymptotes for this function and sketch. So I'm going to start with vertical asymptotes, which was blue. I should actually make a blue pen. So vertical asymptote, you let the denominator equal 0, and you square root both sides, and remember your plus minus, which actually doesn't need to be done right now because it's a 0. I just wanted to make a point, and you end up with x equals 0. Just as an aside, because I want to piece things back together, your domain is x can't equal 0, or does not equal 0. I'm now going to perform the test for the vertical asymptote, and this is the left side, right side test. Fortunately, we only have one vertical asymptote, and we need a number to the left and to the right of 0, so I'm going to go for negative 0.1 and positive 0.1. So 0.1 off, 10 cents off if you're thinking money. So I am going to dig out my calculator for this. So 2 times bracket 0.1 negative bracket to the 3, did you notice that? Minus bracket 0.1 negative bracket squared plus 3 equals, and I get a positive number. Am I ever glad right now that we don't have to worry about actual values? I can take any number and square it and end up with a positive. So we end up with a positive result, which means up. Now I'm going to redo it for this. Just as an aside, I know my denominator will already be positive, and this time I don't really need the brackets because I've got a positive number. So 2 times 0.1 to the 3 minus 0.1 squared plus 3 is a positive value. And that's a positive, so we get up. And at any point, doesn't matter where, depends on where you get overwhelmed with information, or you just don't want to look at stuff anymore, you get to start your picture. That's the point, but not where all the math comes from, or where all the marks come from. So there's my x and y axis drawn with a ruler. Here's my vertical asymptote running vertically, dashed with a ruler, shifted slightly off to the side just so I can see it, and labeled. And now I get to start oblique asymptote, not horizontal, because your top is 1 degree more than your bottom. Let's see if I was smart here. I was. Happens every now and then. So I'm just going to make a little note. And then I undo it. Oh, I have no idea what that is. Let's cover that back up. no horizontal asymptote. So now we're doing the oblique asymptote. And you're thinking to yourself, oh no, this means I have to long divide or synthetic divide. And that is true. You can long divide or synthetically divide. Actually, you can't synthetically divide because this is not linear. This is a monomial. And when it's a monomial, you actually get a special circumstance, and that is you can take 2x cubed and divide it by the x squared, and the subtract x squared and divide it by the x squared, and 3 and divide it by the x squared, because all this means is each of these divided by x squared. You can't do that if it's not a monomial. You can only do that if it's a monomial. Clean this up, clean this up, clean this up. Did you notice what's missing? So that this part is 0, and you end up with an oblique asymptote of y equals 2x minus 1. Now we're going to have to do a test. This was your other version of this, but we now have to do the test, and we have to do it for the 10 and negative 10. I'm going to do negative 10 first just to maintain order, and we have to subtract off the oblique asymptote. This is the part I dislike. So this is not difficult. It should not be difficult for a grade 12 university student heading off to college, university, trade school, wherever you end up going with this course, because I assume you're taking it for a reason. BEDMAS, calculator work, shouldn't be all that difficult. It is super annoying. Like, my hand's cramping right now. So I'm doing as much mental math as I can. And then I'm going to dig out my calculator out of laziness. I could do this. I just don't feel like it. Make sure you finish off the top and see the result. Divide it by 100, which is the denominator. See the result. And then we're going to minus the negative 21, which is adding 21 equals, and I end up with a positive result, which is above. And now I'm going to do the exact same thing with 10. Can you see my handwriting getting messier and messier? That's the hand cramp that's happening. So 2,000 minus 100 plus 3 over 100 minus 20 minus 1 is 19. No bracket necessary. Calculator. 2,000 minus 100 plus 3, see the result, divided by 100, see the result, minus 19 equals a positive answer, which is above. So now I am going to fake sketch 2x minus y equals 2x minus 1. So here's minus 1, and a rise over run, and draw myself this. Now if you look back, you might see another line going in this direction. Your oblique asymptotes do not always have to go diagonally. I don't know if I made so many mistakes that I undeleted or got rid of this information, but I should put an arrow saying up here on the left of my vertical asymptote, and up here on the right of my vertical asymptote. Then I want above on the left of my oblique and above on the right of my oblique. So here's the oblique asymptote. Left is out here, the arrow goes above it. Here is the right hand side, the arrow goes above it. So someday I hope that you will be able to take the guess that these two asymptotes fence that information in. You will probably end up with some x-intercept to run through, and you'll connect those. So that's the guesses that you have to make. So although this sounds really, really dumb to some people, I see this as all the clues in some criminal investigation, and then you have to put a report on somebody's desk about who the criminal is. So this is you taking the clues and giving the report with all the little pieces to it. Yes, you can tell I watch too many crime shows. All right, so this is not easy stuff. It's a lot of work. I'm hoping that some of you at least will be able to take this textbooky box and be able to make a pattern for oblique and horizontal asymptotes, even though it only says horizontal asymptotes. Homework for horizontal is on the bottom of page 42. The website will tell you what to include for oblique asymptotes as well. Next lesson, we'll be slapping all this stuff together. So I will talk to you soon. Under an hour, breaking records.